Welcome to science class. Today we are going to begin a unit on oceanography. Oceanography is the study of the geology, chemistry, physics, and biology of the world's oceans. The topics we will cover in oceanography will include the geography of the oceans, the ocean floor features, ocean zones, ocean currents, and tides. We will not study life in the oceans in this course. We will begin our unit with this video by going on a tour of the oceans. 70% of our planet is ocean, and they contain 97% of all the water on Earth. Despite their vastness, the oceans are a small part of the total composition of Earth. If we removed all of the water from Earth, it would form a sphere about 1,370 kilometers across, much smaller than the Moon. But still, this is a volume of over 1.3 billion cubic kilometers, gigantic on the scale of humans. And without oceans, Earth would be a very dull planet. Life, weather, erosion, none of these would exist on our planet without oceans, or at least without water. In this video, we will explore the 4 world oceans, discuss where they came from, and take a look at zones that divide the ocean. Let's get started. In reality, there is only one world ocean. There's no place in the ocean that you have to cross land in order to get to. But humans obsessively name and categorize everything. So we have the Arctic, Indian, Atlantic, and Pacific Oceans. They vary quite a bit in size and depth. The Pacific Ocean makes up over 32% of the surface of the planet. It is so large that there are parts of the Pacific Ocean. If you traveled straight through the Earth and ended up on the opposite side of the planet, you would still be in the Pacific Ocean. The Pacific has an average depth of just under 4 kilometers. Meanwhile, the Arctic Ocean, the smallest ocean, is only around 7% the size of the Pacific and is only around a fourth the depth of the other oceans. Once again, the boundaries of the oceans are totally arbitrary, but the continents roughly divide each of the ocean basins. There have not always been, and there will not always be 4 oceans. As we discussed in the last video, Earth's first ocean was one big ocean. The entire planet would have been a blue marble with no land poking up whatsoever. When Rodinia and later Pangaea, the supercontinents, existed, there was also just one world ocean. But geologists still divide the one world ocean from this time period like they do with the current one. During the time of Pangaea, the Tethys Ocean sat what you would call inside of all of the continents, while the Pacific or Paleo-Pacific Ocean made up the rest of the world ocean. The Atlantic Ocean continues to grow larger every year, as does the Indian Ocean. The Pacific Ocean gets smaller every year. We have already covered why this is. Mid-ocean ridges are divergent fault boundaries on the ocean floor where magma rises to the surface and drives tectonic plates apart. This is what creates ocean basins, and the process is called seafloor spreading. Seafloor spreading does not continue in the same place forever. After many millions of years, things tend to reverse course, and plates that were once diverging and ocean basins that were growing begin colliding and shrinking. And why does Earth have water? Where did it come from? Earth's water came from the same place the rest of Earth came from: space. Comets contain huge quantities of ice, but meteorites contain tiny amounts of water as well. Again, compared to the size of Earth, there isn't that much water. Even though meteorites only contain tiny amounts of water, and comets are not as common as meteorites would have been during the formation of Earth, that was more than enough water to form what Earth has. The water evaporated to the surface of the molten Earth, since it is less dense than any rocks or metal, and would have been in a gaseous state. When Earth finally cooled, the water collected on the surface. Many moons in our solar system have icy surfaces, but liquid water below these surfaces. In fact, some of these moons, which are much smaller than Earth, contain more water than planet Earth. Ice was more common farther away from the sun, we think, where Jupiter and Saturn formed, and so these moons have collected enormous oceans where life may exist. The other thing we know about the oceans is they are salty. Why are they salty, and what do we mean by salty? The source for the dissolved salt in the oceans is twofold. One major source is from land. Surface water is a tiny bit acidic, and it dissolves weak minerals, like salts, away from rocks, and they eventually flow into the oceans. So then why aren't rivers salty? The amount of salt carried by rivers is microscopic, but that salt, once it reaches to the oceans, can't leave the oceans. Salt does not evaporate, unlike water. It never rains salt water. So there is a one-way path that these dissolves take from land to water, and they continue to accumulate in the water. The other major source are hydrothermal vents on the ocean floor. These are breaks in the ocean floor where water seeps in, and the extreme heat of the nearby mantle causes chemical reactions to take place, which draw out ions from the surrounding rocks and pump them into the oceans. Now, when I say salt, you're probably thinking of sodium chloride, the stuff you put on food. But there are a large quantity of salts. Salts are any chemical compound that contain a combination of positively and negatively charged atoms. These are called ionic compounds. Depending on how you view the definition, all ionic compounds are salts, and all salts are ionic compounds. But generally, salts contain halogen ions, such as chlorine, fluorine, or iodine, and they also contain a metallic element, such as sodium or magnesium. Chlorine alone accounts for 55% of the dissolved ions in ocean water. Sodium accounts for 30%. Magnesium and sulfate, a polyatomic ion, account for 10% of the remaining ions, and a combination of many others make up the final 5%. The salinity of the oceans varies, but the typical range is between 3.5 to 3.8% salt. A liter of ocean water then would have approximately 35 grams of salt in it. The oceans have several different zones. These zones are created by the temperature, density, amount of sunlight, amount of life, and depth. We will briefly list and describe the major zones, and we'll begin with lateral zones. Any and all regions of the open ocean are known as the pelagic zones. The area where land and ocean overlap is known as the intertidal zone. And by overlap, I mean this area constantly changes from dry land to ocean by the rising and falling of the tides, hence the name intertidal zone. As you move further out into the sea, you reach the neritic zone. Let's take a look at the east coast of the United States to understand this one. See how the ocean floor is broad and flat and then suddenly drops off? This relatively shallow, broad, flat region is called the continental shelf. The neritic zone is the portion of the ocean that lies above the continental shelf. The neritic zone covers only about 5% of the world's oceans, but it's home to the greatest abundance of biomass and biodiversity. This is because the water is shallow and warm enough for lots of photosynthetic organisms, but also because it is naturally fertilized by nutrient runoff from land. The rest of the ocean is called the oceanic zone. You'll notice what dictates these pelagic zones is the geography of the ocean floor below. It has nothing to do with the characteristics of the ocean water itself. Vary greatly from place to place. On the east coast of the US, the neritic zone extends several hundred kilometers, while on the west coast it never extends to 100 kilometers. Next, we will discuss vertical zones. The photic zone is the region of the ocean which sunlight penetrates. Typically, this zone is around 200 meters deep, but the first 100 meters is where virtually all photosynthetic organisms live, and this portion is called the euphotic zone. Close to shore, the euphotic zone is much less than 100 meters deep because of sediments, which reduce sunlight's ability to penetrate into the water. Below the photic zone is the aphotic zone, which is officially described as the depths beyond which 1% of sunlight penetrates. There are zones within the aphotic zone, but the uniformity of them is highly consistent. In tropical areas, below a depth of around 1,000 meters, ocean water is barely above freezing, at around 2 degrees Celsius. The sharp drop in temperature as you move into the deep water is known as the thermocline. Closer to the poles, all of the water is about that cold, just above freezing. That concludes this video on ocean geography. Next time, we are going to explore the geology of the ocean floor. Thanks for watching.